now what you do, you okay. So can someone tell, is there any like disadvantage with malloc and free?
Sir, we can set the size only once. Means let us say we want to change the size during runtime, then how will we do using these two?
Okay, so that's a good point. That if you allocate a chunk of memory using malloc for a certain size, like let's say you allocate for 5 bytes or something like that. Okay, so you specify the size in number of bytes. Okay, what you can't do is you can't make that particular thing as 10 bytes. Okay, so for that there is, I think, a function called realloc. Okay, so you can use realloc to use that, so to do that. Okay, so you can resize. If sometimes maybe I think realloc may fail, so in that case also a simpler thing could be that you can simply free that particular 5 byte memory and do a fresh allocation for 10 byte memory. So first you do a fresh allocation for 10 byte memory. You copy the initial portion of the old memory into this newly allocated memory, and then you sort of free the old memory. So this is a very simple. So that is maybe a small problem. A problem in terms of programming style with malloc and free is that it is not very intuitive. So what do we say? What do we mean when we say not very intuitive? So you cannot really you cannot really allocate memory for objects. Okay, or even actually you cannot directly allocate memory for arrays also. So what you have to do, you have to actually calculate the size of the array using the number of elements of the array. Okay, and you have to also and then you have to basically calculate the total memory needed to store that whole array. Okay, so for example, if you are allocating, let's say, 10 integers and you know that integer is 4 bytes, so you will have to actually allocate 40 bytes. And you kind of have to you have to rely on the pointer arithmetic or the things like that to actually make sure that first 4 bytes of that allocated memory corresponds to element 0, second 4 bytes correspond to element 1, and so on and so forth. So that is how it operates. Okay. So it's a very low level thing. Okay, now what C++ does is it provides two new operators. Okay, so one of them is called new. Actually, it provides four new operators. So one of them is called new, which is similar to malloc, so which is for allocating memory dynamically. Okay, but there's a difference. So conceptually speaking, it is to allocate objects. Okay, or instances of types. So instances of either built-in types or instances of user-defined types also. Like if you define a structure or if you define a class, okay, you can create instances of those using the new. So that is the sort of conceptual difference between malloc. And so from the programmer point of view, you are not just allocating memory, you are actually creating a new object, okay, for of a particular type. Okay, so that is what new does. Okay, and similarly delete is something like corresponding to free. Okay. So what delete does is it basically frees the memory allocated by a new operator. Okay. Okay. So there are two more operators. These are called the array versions of new and delete. Okay. So these are to create arrays of objects, and the array version of delete is to delete an array of objects. Okay. There is also a third version which is called the placement new. Okay, where you can which actually doesn't allocate memory, but it creates, so it takes as input pointers. Okay, so we will see what each of these does in great detail shortly. Okay. Okay, and yeah, so so let us go ahead. Okay, so I think we have already discussed some part of it. Okay, so here on the left is a typical usage of the malloc which we were describing. So I think all of you know this. Please stop me if some of you don't understand the left program, but I think it's fairly obvious that you create a pointer and then of type int, and then you want to create an integer, so you just use malloc to allocate a memory which is same as the size of integer, and then you can use star of p as that particular thing. Okay. Um, yeah. So in the C++ program also you can, by the way, use malloc. Okay. So it is available to you in the C++ program. Okay. So, and it is there in stdlib.h. Yeah. So size of int needs to be provided. Yeah. So yeah. And yeah. So the other thing is that pointer to the memory allocated is of void star. So basically void star, yeah. So and then it needs to be cast to the type int star in order for it to be like allocated to actually an int star. Okay, because a pointer to an int. Okay, yeah. Uh, yeah, and allocated memory is released by free from the heap, and yeah, calloc and realloc are also available. Okay, so both functions are available. Okay, um, okay. Um, Now here is basically the same thing. Uh, so left is the same program that we saw in the previous slide. Okay, right is the same program using the operators new and delete in C++. Okay, so you can see that what you do is you here also you have a pointer of the type. Okay, so in this case integer, it's of type int. Okay, and you just say new. So new is a keyword in C++. Both new and delete are keywords in C++. So you say new and then you say int. Okay, and then within bracket you can also provide an initializer. Okay, so a value to initialize this particular thing. Okay, this particular element. So you provide 5. Okay, so if you print 5 here, and then you can delete p, and then you are done. So let us see. So operator new for yeah, allocation on heap, or yeah, this is also called free store. Okay, because yeah, sometimes so as you shall see that you can overload new to do all kind of things, not just on heap. And yeah, so we will see. Okay. Yeah, no size specification is needed. Okay. So you see this new operator is taking, so this is the argument to the new operator, right? So the new operator is actually taking an object of type int. Okay. So okay. uh, Now allocated memory is returned as int start, so no casting is needed. Okay. And you can also initialize. Of course, you can initialize using malloc also. You can just redefine to malloc to say I want to initialize something. Okay. Uh, or yeah, but here it is kind of built in. Okay. Okay. Uh,
Sir,
yes.
sir, since both new and malloc give allocation on heap, why can't we free? I mean, use the free operation on object which is created by new.
Yes. So because you see, it is not guaranteed that we will come to in a minute. So new operator may use its own heap, for example. So so it is not guaranteed that the new operator will only use malloc for memory allocation. Okay, is this clear? So just bear with me. It will become more clear that you can actually overload the new operator also. So there are two. So actually, I will give two answers to this. So this is a good. So this is one thing that sort of a thing that I wanted to tell, that you should never mix malloc and new. So malloc free and new delete. Okay, so this is like you should never do this. Okay, and there are multiple reasons why you should not do this. Okay, so one reason is that new, as you can see, does something more than just allocate memory. Okay, um, so delete undoes the corresponding things. Okay, so I mean to be so for those of you who know, for example, constructors and all, so new calls the constructor, delete calls the destructor. Okay, but malloc free will not do that. Okay, so conceptually speaking, okay, new and delete do more than just allocate memory. So this is the number one reason why you should not call new and then use free to try to free that. Okay, this is one of the reasons. The other reason is what I just told, that you cannot be sure that the new operator is actually using the same heap as malloc. So for all you know, a particular library could have redefined the whole thing, and there are many things that people do. So there are there are situations where you have to have a very fast allocation. Okay, so there people may not use malloc. They may actually there are libraries which actually allocate a huge store of memory once, and then they redefine the new and the delete to actually allocate subsets of that memory. Okay, so this is one of the things somebody may do. Okay, some library may do. Okay, there are many things that people do. Okay, so you can, for example, initialize. Similarly, you can use delete to actually zero out the contents of a particular memory you have freed. Okay, and that may be useful for security reasons. Okay, because after you have freed the data, you don't want that data to be residing in that particular memory. Okay, I'm just telling you. So I hope I'm able to give you an idea that actually malloc and free are very, very low level operators. Okay, they just allocate and free memory. Okay, so new and delete are conceptually speaking, that is why I'm just saying you should think of new and delete operators as creating objects and deleting objects. Okay, rather than just allocating memories and freeing memories. So does this clarify that point?
Yes, sir.
Okay. Okay, a little bit maybe. Yeah. Okay, we will go and see more. Okay. So now,
I
yes,
had a doubt.
is there a
Like,
question?
like,
Yes.
so like I didn't get what is meant by like cannot be initialized in case of malloc and free and can be initialized in case of new and delete. Like, could you explain it once again, please?
Okay, it's not so cannot be initialized basically means that malloc per se does not initialize. Okay, so that is how I would, and can be initialized as you can see here. New int 5 here, actually you are not doing star of p is equal to 5 anymore. So when you are allocating the memory, you are automatically setting it to the value 5.
Okay.
Does that clarify?
Yeah, like when like just in the memory allocation step, we can like set it to the object value, like what value we want for that object, but that's not possible in a single step in case of malloc, right?
Right, right. So at this point, like after the malloc has executed, if you try to print star of p, it will hold a garbage value. Only after star of p has been assigned 5, okay, that you will actually see the value of 5 in star of p. But here, just after this new int 5 has executed, if you print, so you will get 5. Basically, that is the difference. Okay, I think that is
Okay.
clear. Okay.
And
Yeah.
so, like, in case of, like, could you just scroll to the previous page? Like, in case of new int, can we leave the argument blank, right? Star, like, star p
You
equal to
can.
new. Okay,
You
then
can
it
do
would hold garbage value, right?
that. Yes. So if you
Okay.
don't, if you leave the argument blank, it will not initialize. Okay. Okay. Uh, okay. So let us go ahead. Yeah. So okay. So now we have already seen operator overloading. Okay, so and we just told you that new and delete are operators. Okay, so what happens is that new so C++ provides you the and for operator overloading we told that I mean most operators, they have a corresponding function which is the operator function. Okay, so corresponding to new and delete also there is a corresponding operator function. Okay, and those functions are basically operator space new and operator space delete. Okay, so that is how you can get you basically can get those operators. Okay, so now here there is a caveat. Okay, the operator new function is not same as new. Okay, operator new function operates very similarly or almost exactly similarly as malloc. Okay, so you see to the left, we have given again the old code where you sort of use malloc to allocate memory. Similarly, you can also use this operator new function to allocate memory. And there again, so it has a similar behavior. So it takes the size of the memory to be allocated in bytes as input. Okay, it allocates that memory, okay, and then it returns pointer to that the address of that particular allocated memory as a void star pointer, and then you can recast it to int star in this case to assign it here, okay. So so the difference is, see, so here you must observe the difference that malloc is actually part of the uh, the C++ library, okay, this stdlib, okay, but the new operator is standard in C++, okay. So okay, yeah, so yeah, so this is the so this is one of the other differences. So if you use, actually here you see for malloc you had to include stdlib, okay, but for using the new you did not have to include stdlib, okay. Here actually stdlib is there, but for using operator new you don't have to include stdlib, okay. So that is the other thing, that the new operator comes as a standard, you know, it's a language feature, not a library feature, okay. Whereas malloc is a library feature in C, okay. Okay. Uh, yeah. So the function operator new, yeah, okay. So the function operator new is used for allocation on the heap, and the function operator delete is used for uh, you know, deallocation in heap. And this is an important point. I think we have already highlighted this. The actual operator new and the function operator space new, these are very, very different, okay. Calling, so if you call operator new, okay, if you call the function operator new, it does not do the same thing as using the actual operator which is new, okay. Okay. Now you have seen already how to create single objects. So yes, so
I had a doubt in the last slide
yes,
in the
yes.
operator new in and in malloc.
Mhm.
Sir, since the data means it's almost working almost similar, is there any difference between malloc and operator new? Like it is also typecasting the pointer and it is also taking the size and not initializing at that point only.
Yes. So again, you should not mix. Okay, so the good question. So the question is, suppose you allocate, just because you know it is taking size of int and it is returning void star. If you allocate using operator new, can you for example free using the free function, right? That could be one question, right? So answer is no. Okay, they are not same. So what is the difference? I just told one difference. Okay, so the operator new in C++ comes as a language feature. Okay, a malloc is a library. Okay, so there is no guarantee. Okay, so in some implementation of some compiler, okay, the operator new may use malloc. Okay, but there is no guarantee of that. Clear?
Yes, sir.
So for the code on the right hand side of the slide, we do not need to include cstdlib, right?
Yes, yes, yes. You don't need stability.
Okay, sir, understood. And these will work on a separate heap from malloc and free. They may or may not.
May or may not work on a separate heap, or they may use not even use a heap. So yeah.
Okay, sir, understood.
Hmm. Hmm. Okay.
Sir, if they don't use heap, can we use in functions to allocate memory?
Yes, we will come to just wait for we will come to that. Huh? So you can actually use new to allocate. So we have an example for that. Huh?
No, sir, operator new. I was asking about that.
Yes, operator new. You are saying operator new function?
Yes, sir.
So sorry, I am not understanding the question. Are you saying that is the question that can operator new function allocate memory on stack? Is that what you're asking? I'm not understanding the question. Sorry.
But you said that operator new may or may not use heap. So if it does not use heap, can we use it to allocate memory in functions, which will die down after the function call?
Okay, so what you are thinking is that there are only two areas, the stack or the heap. That is not the case. So there will be a third area called free store, okay, which is neither part of a heap, okay, as maintained by malloc, nor nor part of the stack either. So it is part of the process memory, but it is not part of either the heap or the stack. Clear? So it may be a third memory also. But yes, so to answer your question, if you use operator new to allocate memory within a function, it will be available throughout the program until you call delete. Okay, so does that answer your question?
Yes, sir. Thank you.
Okay. 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 So okay. So now we go into this thing that how to use the array. Okay. So again, in the left, I think you can easily understand what is happening in the left. I'm not explaining it anymore. You are trying to allocate memory for an array of integers of size 3. Okay. So in the right, you can see how to do it using the array new operator. Okay. So you basically say new int, and then within square bracket, you can say 3. Okay. So this will allocate memory for the so this will allocate memory for the for basically 3 integers, and you can access them exactly like arrays. Okay. And for deleting, you have to use the array delete operator, which is delete followed by open and close bracket, and then you give it the pointer. Okay. Yeah. So here again, the allocation is by operator new within brackets. Okay. So which is a different so which is a different operator. Okay. Number of elements is explicitly passed to the operator new. Okay. And released by delete again, which is different from the delete operator. So remember, if you use the normal delete operator here, it will result in problems. Okay. So when you do an allocation using the array new operator, you should only delete using the array delete operator and vice versa. Okay. So you should never mix and match the array new with the normal new also. Okay. Okay. So okay. Now, as we were discussing, so there is a version of the new operator which is called the placement new operator. Okay. So what the placement new operator does is it takes as input an address. Okay. and then it doesn't allocate memory. It simply creates an object in that at that address of size of type, which is the next argument basically in this case. So in this, let us look at this particular statement here. So what it is doing is it is creating an object of type int, so which is basically an int, okay, an integer object, okay, at this location buff. Okay, so earlier you have created this unsigned char buff, okay, which is enough to hold two integers basically. So this is probably of size 8, okay. Okay, so now you see, you are saying, so the first integer is you are creating an integer at the address location buff, okay. Now this address location, remember, this is on the stack, okay, and this will be unallocated when the function exits, okay. Nonetheless, it is being created and it is being initialized with 3, okay. The second q integer, okay, is being created at address buff plus size of int. So you know this. So this is basically, if size of int is 4, then buff plus 4, okay. Okay, so here I mean, you can see that size of buff, I mean, this type of buff is actually unsigned char star, okay. So otherwise you will have to factor in accordingly, okay. So this is basically buff, the pointer buff increments by 1 byte only, okay. Now you have to and then it is initialized to 5, okay. Okay, okay, and then there is you are creating this this pointer to buffer, and then p buff, okay, and then pointer to q buff, okay. And then basically what you can see is that you can just print address of this p buff and q buff and p int and q int, and you will see that these addresses are exactly same, okay. So you can just run this program and check, okay. But when you use the normal new operator here, okay, you will see that it creates an address in the heap. So yeah, so basically you can see that yeah, so basically the buffer address and the integer address, or this p int that you have created, address are the same, okay, but this address is very, very different, okay. So you can see it here, okay. Yeah, so another important thing is, when you are using the placement new operator, you must not call delete on them, okay. So because delete there is no placement delete operator, okay, as such, okay. So yeah, and nothing needs to be yeah, so that is the thing, okay. Okay, okay, so
Sir,
yeah, yes.
I had a doubt in the previous slide. Can you means a placement new in buffer buff, like new bracket buff int 3. So can you explain what exactly this operation does?
Okay, so it provides this buff as argument to the new, okay, and then so what is your question exactly? So I
Like
mean,
this new integer is created at the address of buff. Does this statement mean this?
yes. So the new integer which will be created and initialized to 3 will be located at address buff, but no memory will be allocated.
But we have already created memory to store address in the array of buff.
Exactly. So see, now think, okay? This is what I'm telling from the beginning. There is a difference between creating objects and allocating memories. Right. Allocating memory does not, create objects. Okay. So for simple thing here is, if you just allocate memory for an integer, will that be initialized to 3? No, right? Okay.
Means using new operator we can do, right? For it.
No, please try to understand what I'm saying. Okay. Creating objects, part of that is allocating memory, not in this case. In case of placement new, it is not. But in general, you should view new as not just allocating memory, but as creating objects. So there are other things that need to be done to create objects. For example, in this case, if I did a new, so take this one, for example, new int 7. Okay, I'm doing here, no, new int 7. Okay, this is allocating memory, but is that all it is doing, or is it doing something more?
Initialization to 7.
Initialization, and also see, it is casting the return pointer of type int. Okay, so both. So now when you access it through our int, the compiler will know that it is actually this particular location is actually storing an int, right? You understand the difference?
Yes.
So there are more things that you do when you create an object. Understood? Than just allocating memory. So this placement new does everything about creating object except the memory allocation part. Clear?
Okay, sir.
Sir, also, sir, like we initialize the buff as a character array, but
Right.
then we are putting an integer in there.
Right. So basically you cannot, so if you use the buff as a character array, then this integer will be overwritten. But here you are basically initializing this as a character array just so that you are so I guess so you could have initialized this as any other type of array. Okay, you could have also done a buff as a malloc also. Okay, void start type also. Okay, is this clear? So the purpose of initializing not initializing, but so this is called defining. Okay, so you are defining buff as a character array just so that you sort of allocate that amount of memory on the stack.
Professor Shorangshu, could I make some comments here?
Yes.
See, students, first of all, both malloc and new does dynamic allocation. That is the only common thing between them. Otherwise, there is a sea of difference between these two. So, Professor Shorangshu has pointed out quite a few of them. First of all, malloc is a library function and new is a predefined operator in the language which can be overloaded. Now, if you look at the parameter of the malloc function, it just takes a number, right? It takes a number which is an unsigned integer, which is type aliased by the name size underscore t in the library. That number denotes the number of bytes that you want. So malloc does not know what kind of object you want to place at the location that you are requisitioning from the system. So it has no way other than to give you a pointer to void star. That is, it is a pointer to that location, and that pointer does not also know what type of object will be placed there. It also does not know, after the allocation, it also does not know. Excuse me.
Hello. Professor PPD.
Sorry. I just.
Oh, okay.
Yes, I'm here. Sorry. So now when you are doing new, look at the call to new very carefully. New is an operator and it is a prefix operator, first of all. Unlike most of the other operators that we have seen, not all, but most of the other operators were infix, except for plus plus, minus minus, or simple minus, simple plus. New is a prefix operator. So you first have the operator name. Now, what is the parameter to new? That is most interesting to see. The parameter to new is a type. Parameter to new is not a number, is not a size t, it is a type. You are saying new int. If you have defined a structure, say complex, which has two fields, real and imaginary, and want to allocate it through new, you will say struct new struct complex. So new takes a type. That makes it very, very different. Now, what does new do? New does the first step new should do, forget about placement new to start with. But the first task that new has to do is to allocate memory. Now, malloc knew that it will have to allocate so many size t number of bytes. How does new know that? New does not know. So what does new do? It knows a type, that the type of the object you want to allocate at that place.
Yeah, sorry, I got disconnected, I think.
Okay, not a problem. So new knows the type, so it does a size of on that type. What is size of operator? It is another prefix operator which takes a type and gives you the number of bytes required to store an object of that type. So new first will do a size of on the type. It gets to know how many bytes it has to allocate. Second step new will do is to call an allocator function. Now, which allocator function it will call is a choice that is given to the compiler writer for the system provided new. That is a choice given to the user if you are overloading new. The common choices are, it could use malloc itself, because malloc does that specific job. Given the number of bytes, it will allocate those many bytes requesting the system. Or it could use the operator new function, or it could use anything else. It does not matter. The second step is to do this allocation, which is blocking a chunk of memory on the free store and getting a pointer to that. And how many bytes do you block? As is the size of the type that new has got. Okay. After having done this second step, new has a pointer. New has two information now. It knows the type of the object to be created, and it knows the pointer to the memory location where that object has to be placed. So the third step it does, it constructs the object, a process which we will study when we do the classes. For now, just assume that it does enough to create the proper organization of that structure or the class or the simple variable object in the memory whose address new has got. This is called the construction process. The fourth thing, once that has been done, now while you do the construct, the question is, do you know the initial value of that object? You may not. So new has an optional parameter, which is the initial value. So that is the third thing new is getting to know. It knows the type, it knows the size, pointed to the location where the object will be created. Now it gets to see also what is the initial value. If it does, it is optional. So when you are doing, say, new int within simple parenthesis 7, the 7 is the initial value of the int object. So if it knows the int object, then after construction or during construction, in the third step, it also does the initialization. If initialization is not given, it does a default construction, and the object or its different fields are not populated. The last step new does is it returns the pointer to the memory location that has been allocated. Unlike malloc, which did not know the type, new knows the type. So malloc had to return a void star. New can return a pointer of the specific type for which new was requested. So this is the whole story of new. That is getting a type, finding the size, using an allocator to allocate memory, constructing and initializing the object, and returning a pointer to that memory of the same type as requested in the new. Right? This is the whole thing new is getting to see. Okay. Is this part clear? Then I will talk about the next steps.
Yes,
Is
sir.
this clear?
Yes, sir.
Right. Okay. Now let us look into what will delete do. Then I'll come back to other variants of new. What will delete do? Delete has to do two things. One is, since the object has been constructed, the same object will have to be destructed before the memory can be released. Free does not have this responsibility. All that free has to do is malloc has allocated a memory. It knows the pointer to that. Free will take that pointer and deallocate that to the system. Now the question again is, when free does, how does free get to know how many bytes were allocated? Free does not need to know that, because system maintains a table where for every allocation, it maintains how many bytes were given to it. Right? So free will simply do the deallocation, that is, release the memory so that others can use it. Now delete, corresponding to the new, will have to do the same thing. It has to do the deallocation. But before that, it has to make sure that the object is properly deinitialized. What does this deinitialization or destruction mean? It means that the object may have allocated some memory inside it. Object may have, you may want that when the object is actually getting destructed, you may want a message to be displayed. You may want some packets to be sent, so on and so forth. So delete first has to do the matching destruction process, matching the construction of the new, and then it will do the deallocation. So now when it does the deallocation, it becomes critical that delete does the deallocation using the matching deallocator that new had used. So if new had used malloc, delete should use free. If new had used operator new function, delete should use operator delete function. If new had used a user-defined allocator, delete should use a matching user-defined deallocator that the user must provide. That is the reason new and delete will have to be matched. Is this point clear? Then I'll proceed again.
Yes, sir.
Okay, good. Now let us look at how does new of a single object differ from the new of an array of objects. So what we say is array new, written by that square symbol. Now, when you do array new, what you are telling new are, earlier you were just telling the type. When you are doing array new, you are telling two things. One is the type, another is the number of elements of that type that needs to be consecutively created in the allocated memory, right? Because it is an array. So if it is an array of 5 elements, 5 integers, then 5 integers will have to be created. So it new needs to know that number. Okay, having said that, what will new be doing? The first step is to allocate. So for that, it needs to know the size of the memory it needs. So it will get the size of the memory by doing two calculations. One is it will do the size of on the type to get the size of every object. Then it has to multiply it with the number of elements that have been asked for the array so that it gets the total size. That is simple. Once it got the total size, the next step would be use the allocated, which is similar to the way single object new. It will use the allocated, get that whole space allocated in the memory, interacting with the system. The third step of construction now needs this information about how many objects are there. Because if I have created an array of 5 objects, then I have to create 5 objects, one after the other. So new now has to do as many construction of objects as are specified in the dimension of the array. How many elements? How does it do it? It knows the initial pointer. So it constructs the 0th object at that pointer value. Then it increments that pointer by the size of the type. So it knows the address of the first element in the array 1 element. It constructs the array 1 object at that memory. Then it again increments by the size of the type, keeps on doing that as many elements are there. Now, once the construction is done, then it will return a pointer. It notes the type, return a pointer of that type to the first element of the array. This is what array new is doing. So two things have got different. One is it came to know about the number of elements are there in the array. And two is if the number of elements is 5, it had to do 5 constructions. If the number of elements is 10, it had to do 10 constructions and so on. So what will the corresponding delete has to do? The corresponding delete, the earlier delete was just doing deconstruction, destruction of one object. Now it has 5 objects. So it has to do destruction of 5 objects, scanning it, starting from the 0th object, and then going over that array, incrementing every time by the size of the type, and do destruction for 5 objects. And after the destruction of 5 objects are done, it will do the deallocation in the same way. So you can see that there is a difference between delete and array delete, because delete just has to do the destruction at the given pointer, whereas array delete has to go over the elements and destroy each one of it. Now this raises a question that how does delete get to know how many elements are there? What we are giving delete is a pointer, right? The system maintains against the pointer, the system maintains how much space was allocated. So suppose I'm creating an array of 5 elements of type integer. Suppose that size of integer is 4 bytes. So the total space allocated is 20 bytes. System knows that, maintains it in a table that given the pointer value, 20 bytes are allocated. So, but when the array delete has to work, it has to also know, it will not know whether these 20 bytes are one single object of 20 byte size, or 2 objects of 10 bytes each, or 5 objects of 4 bytes each and so on. Unless it knows that, it cannot stride along the array to destruct as many objects as are there in that array, right? So what delete needs to know is also the number of elements in the array. Now that is the question, how does delete get to know that? Now there are several schemes for doing that. One scheme is you keep that information in the so-called header of the array itself. That is, when new is allocating, it not only allocates the number of bytes required for the array, but it allocates some additional space before the first element, let's say. And in that space, it writes down how many elements are there in the array. So you have got a memory. Initially, that memory starts with the number of bytes, number of elements in the array, and then it starts with the actual 0th element. What you get as a pointer is a pointer to the 0th element, but before that, the number of elements in the array are written. Array delete knows this. So what will array delete do? Array delete gets a pointer, it knows a pointer to the 0th element, it goes backwards, finds the number of elements in the array, and accordingly does those many destructions. So you can see array delete has a very different behavior from the single element delete. Right? Is this clear?
Sir, what is the difference between destruction and deallocation?
Destruction is erasing out the object. For example, suppose, think about a list. You have done list in PDS course, right? You did?
Yes, sir.
Yes or no? Yes, right? Say yes confidently. So a list has a node. List is a list of nodes. What does node have? Node has a data and a pointer. And that pointer allocates another memory. Right? So if I have to release a node, if I have to deallocate a node, that is, I'm forgetting about that. I'm telling the system that this memory is no more needed by me. I need to make sure that the data that was pointed to by the pointer inside that node must also be released. Otherwise, I'll forget about that. So the destruction is the process which ensures this kind of activities. So that anything that may be hanging from that object are also properly destroyed and deallocated. There could be several other kind of things also that the destruction will do. And deallocation is the physical negotiation process with the system, typically called the memory manager in the system, which informs the system that this memory is no more required by my process. Is this difference clear?
Yes, sir.
Right? So we have understood new, we have understood array new. New has corresponding delete, array new has corresponding array delete. Now the third, which you are seeing on your program 10.07 here, is placement new. What does that say? You say that no, I do not want a dynamic allocation. I would provide the memory to new. And I want the object to be created in that memory itself. So now this placement new operator is getting three information. One is the type of the object. One is the initialization value if it is there. And the third is a pointer to a buffer of bytes. That is, it is just a chunk of memory. It's a pointer to a buffer of bytes. Do not get confused with the unsigned cat type. Unsigned cat type is basically There is no byte type in C or C++. And every type in C or C++ has a size which is system dependent, right? Like int could be 4 bytes, long could be 8 bytes, but in some system, int could be 8 bytes, and so on. But the language defines, this is defined in the language standard, that unsigned char must be of 1 byte. No matter what you do, unsigned char must be of 1 byte. So what you write as unsigned char, what you should mentally think is basically a byte type. It is just consecutive number of bytes that you get. Now, whether you treat it as a sequence of characters and in every byte you create a character, or you take it as a sequence of 4 consecutive bytes each and create an integer in each one of them, is your choice. But this is a nice way to specify an arbitrary chunk of memory, which I already have in the program. That is my buffer. So I tell that buffer the type and the option and initialization value to new. So what will new know? New knows the size. If new knows the size, new knows the type. If it knows the type, it knows the size. So as it knows the size, it can create the object. But the second step of new, which was allocation, is no more required because the memory is already provided. So new finds out the size, skips the allocation part, and then goes on to construct the object with the initialization, and then returns that same pointer where the object has been created. The programmer had given the type to new, so the programmer knows the size of the object that has been created in that allocation, in that buffer. So the buffer has to be, first requirement for this, the buffer has to be large enough to create that object, to accommodate that object. Otherwise you will have runtime error. If it is large enough, suppose you are creating an int and you have given a buffer of 10 bytes, then the first 4 bytes will be that int and the remaining 6 bytes will remain unused. It is up to the programmer to manage that. So what you are doing in placement new, you are kind of becoming a memory manager for your system instead of relying on the system's memory manager. So placement new simply skips the allocation part. Rest of the things it has to do exactly in the same way. So what will be placement delete? Now placement delete is not provided for the simple reason that you do not have a deallocation to do. The basic principle of delete is deallocation. So if you allocate a object in a buffer by placement new, it is your responsibility to destroy that object. There will be no explicit, there cannot be an explicit delete for it. So placement new will not have a delete corresponding to it. Does this clarify?
Sir, can you explain the difference between pint, allocation in pint and pbuff?
Pardon?
Sir, in allocation, like in placement new,
Yes.
we allotted the value, like initiated the value. And what are we doing in pbuff?
Pbuff is a buffer. It is the same thing, but through the pointer you are taking different views. So if you print the address, that is the reason the addresses are printed at the bottom. If you look at it as pbuff and you try to stride, you will stride as 1 byte, because pbuff is a pointer, not what is pbuff. No, not pbuff. Buff. Buff is an array of single bytes. So if you stride buff, you will get single bytes. When you get pint, you get a pointer, initial pointer to the same array. but that pointer is viewing that memory as if it is an integer. So pint, since it has a type integer, after new has been done, we'll expect to read 4 bytes in one chunk and expect to see the initialized value 3 in that. Qint has been allocated after that. You can see buff plus size of int, because pint is pointing to the first integer. So the next free space is the beginning of the array plus size of one integer. So buff plus size of int. That is where qint has been created. So qint is pointing to the same buffer at the buff location buff 4, because 0, 1, 2, 3 are taken by pint. It will pointing to buff 4, where 4, 5, 6, 7 are taken by qint, containing a value 5. That is the basic difference, right? Got that?
No, sir. After that, what are we doing in pbuff?
Pbuff is we are just directly creating a pointer. We are just trying to show that what you have got is basically a stride of ints on the buffer. So pbuff is buff plus 0, which means it is buff 0. That pointer has a type cat, unsigned cat star. We are casting it to int star. So we are saying that let pbuff think that it is an integer, which actually it is. So pbuff and pint must have the same value. Then we are doing qbuff, which is buff plus size of int. That is buff 0 plus size of int is 4 bytes that we are skipping for the first integer. So qbuff will point to buff 4, and we are casting that to int star to say that in qbuff you will find an integer. So qbuff and qint will be the same. The reason we have shown this is to show you that actually in the buffer, in the pint and qint, it is going through the new operator, and you're passing the buffer, all this, you don't get to see what's actually happening. But pbuff and qbuff are directly pointers to the buffer. And we are showing that if you point to the right address and take the right number of bytes on the buffer, you actually get the object that you have created. So this is just to demonstrate that. Does that clarify?
Yes.
Got it?
Sir?
Yes.
Sir, you said like for deleting an object which has been allocated some memory, you said that first we deconstruct that object and we delete the hanging variables inside it, and then we deallocate the memory.
Right.
So, sir, in the new placement operator, first we are allocating the memory through the buffer, and then we are creating the object using the new placement operator.
Yeah, you are not allocating because you have got that. New
Yes,
has
sir.
got that pointer.
Now, sir, as you said, there is no delete for placement new. And if I
Yes.
were to delete the memory allocated through the buffer, it wouldn't be
You have
proper,
to
right,
directly
sir?
call the destructor.
Okay.
You have to directly call the destructor. For example, if I have to destroy the integer allocated at pint, I have to do pint pointer tilde int bracket. I will not do that because int is a built-in type, and built-in types do not need destructors, because they are always defining values which are predefined. But if you have your own type, which we'll come to later on, you will see that you will have to actually directly call the destructor if you have something to be destroyed, in case of matching the placement new.
Okay, sir.
Got it?
Sir. Yes, sir.
Sir,
So the lesson is, if you are doing malloc, use free. If you are doing new, use delete. If you are doing array new, use array delete. If you are doing placement new, remember to destroy yourself, no delete. And do not mix any one of them, because I have told you clearly how the algorithms used in each one of them are different. And therefore, the system's internal data structures are different. So if you use one kind of new and a different kind of delete, then you will either get a runtime segmentation fault kind of error, or you will have an unexpected result. Clear?
Sir,
Yes, sir, it's clear, sir.
excuse me, sir.
Yes.
Yeah. Sir, does the destructor resets all the bits? Like, what does the destructor do?
No, it doesn't. It doesn't. What the destructor do, we will come to when we talk about destructors.
Sir, so if we just deallocate the memory, won't it suffice?
I gave the list example. If you deallocate the node, there's no harm in terms of the int part of the data which is possibly int. But in the pointer, you are holding another node. So you will lose that pointer. So you will not know what other data you are holding. So you will not be able to access or release that second node.
Oh, yeah, okay, sir. Thank you.
That will get lost. That is the problem. Right? Clear?
Yes, sir.
Sir, in that linked list example, sir, so basically, when we delete the deconstructor will basically delete the memory where we have stored the reference to the next node and reference to the data inside that node.
I mean, that is up to the user to decide what needs to be done. This is one example I gave. In a linked list, yes. If you are trying to do a delete on the header, the entire list has to be first one by one deleted before you can delete the header, right?
Yes, sir.
Otherwise, you will lose the whole list information. But this is just an example. There could be several other information that an object might hold, which you want to release. For example, it could hold, during construction, I could have acquired, or even afterwards, I could have acquired a lock on a particular database table. So unless I release that, I will continue to hold that lock and no one else will be able to access that table. So the destructor one needs to release that lock. In a graphics program, I have taken a lock on the screen. Several graphics programs need to do that. That when that program is drawing, no other program should be drawing on the screen. So I've taken the lock. And now without destruction, without releasing that lock, if I just deallocate that object, the system will continue to think that I'm holding the lock and no one else will be allowed to draw anything on the screen. Right? So you can see the kind of difficulties you can get into.
Yes, sir. Got it, sir.
Sorry, Professor Shorangshu, I took a lot of time, but I thought we will just clarify these concepts.
Right. So I think today we have run out of time. So yeah. So we will continue with overloading of the new operator in the next class. And okay. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
So please stop recording.